I got my PhD here from the University of Kansas in 1989, working under the direction of Professor Ted Kuwana. And when I was at KU, my PhD was involved in developing bioanalytical tools for doing various biological discovery applications. And then my postdoc was part of an ongoing project at Los Alamos National Laboratory, where we were working on new technologies for sequencing the genome. And my research focus has been primarily based upon those undergraduate and postdoctoral experiences in developing new tools for biological discovery and also clinical applications. So there's both a fundamental research and a translational component to what I do. And part of this, we actually have been engaged in using what's called microfluidics, developing plastic chips that are used for a lot of the tools that we generate. We have a lot of collaborations with the KU Medical School, particularly the Cancer Center. And let me give you a couple of examples of projects that we've been working on with people at the medical center. We actually have laboratories in the medical center too. So one of them is looking for children with leukemia, acute lymphoblastic leukemia in particular, and this is with Children's Mercy Hospital. So what we're doing on this front is actually isolating leukemia cells out of the blood of these patients and look to see how they're responding to therapy. So this is a microfluidic chip that has antibodies in it that's looking specifically for these leukemia cells, and then looking at the genetic makeup and the composition of those cells to see how people are responding to therapy, and is there any sign of recurrence after they've been successfully treated. The other project that we have going on at KUMC, with people at KUMC, is in multiple myeloma. And this is also a liquid-based cancer. And in this particular case, we have developed chips for gathering up plasma cells, non-natural plasma cells that are associated with multiple myeloma. And then looking at chromosomal aberrations in those multiple myeloma cells. And this can actually serve as a prognostic indicator to decide how to treat those patients. So we have one of the world's best clean room facilities in the US. It's an amazing new resource that allows us to do fabrication, build things on the nanometer to micrometer scale level, and then using new techniques such as injection molding to produce parts with nanometer to micrometer scale dimensions, and then use those techniques to move into the clinic. The research in my lab is dictated by the graduate students in my lab. They drive everything. We come up with an idea of a project based either on new ideas that the students may have, or funding that I have on a lot of these, if not all of these projects. Then they come in, they design experiments, they actually start implementing these experiments and reporting back to me what the results are on these experiments. And then what's really interesting is actually designing new experiments predicated on results that they found. I've had over 68 people get their PhD with me over the 30 years I've been in academics, and they've taken on job responsibilities and roles in academia as professors. I have people that have gone into government labs. I've had people go in and work with publishing companies to help bring new articles to really top-tier journals. And then most importantly, I've had a lot of students go into the private sector, pharmaceutical companies, technology development companies. For graduate students, I'm a KU grad. I'm an alumni. I got my PhD here at Kansas, and it's the best place to actually be. It really helps you with your professional career with a lot of great faculty that are here to help move things forward for you and what your career aspirations are.